Okay, in this video I'm going to continue on with exercise 6a of the book Fundamental Applied Mathematics. We're on page number 156 and the question is 3. It reads, a sledge is pulled across horizontal ground by a pulling force of 130 newtons. The force makes an angle A where tan A is 5/12 with the ground. If the sledge moves a distance 50 meters, find the work done. If this took 1 minute, find the power. So I've sketched the motion there in front of you. Now you've got to remember the following. We've defined work, not F, we've defined work done is equal to the product of the force and the displacement. We've also realized that it's actually the force parallel to the displacement, and as a result it becomes F times the cosine of theta times the displacement. Okay, so let's just apply this here. If we want to get F parallel, we need to resolve the vector F into its component unit vectors. I'm going to define I hat in this direction and j hat in this direction. So look, we're well used to resolving a vector. So if you've got the vector A, the acceleration vector A, we want to find the two vectors which when added together create that vector, and they must be parallel to the unit vectors. So this is parallel to the I, this is parallel to the j. They're at right angles and they must be in these directions here. Where I call this angle here or theta, we have a sub y in the j hat direction and a sub x in the I hat direction. And we know of course that the vector A is equal to a sub x I hat plus a sub y j hat. So this turns out to be a times the sine of theta j hat, and this turns out to be a times the cosine of theta I hat. So we get a cos theta I plus a sine theta j hat. Alright, that's just a quick revision there and something you're probably sick of at this stage. So let's just do the exact same thing with our force vector F. So the force vector F, I'll do it very quickly. It becomes F times the cosine of A, and the cosine is 12 over 13. So it just becomes 130 times 12 over 13 I hat, and it becomes 130 times 5 over 13 j hat. Both of them are, of course, in the plus direction. Now, F parallel is clearly the I hat, okay, because S is 50 meters in the I hat direction. So we get the work done is equal to F parallel times the displacement vector, which is equal to, what's that, 120 times 50 is equal to 6,000 joules. Alright, the next thing is we want to get the power, so we find the average power is equal to the work done times, divided by the time. So we get 6,000 joules divided by 60 seconds. Because of course we're talking about SI units, and the SI unit for time is the second. So we get 60 here, divide the two of those, and we get 100 watts. Alright, that's all I've got to say about that. Thanks for watching. Please pass it on to your friends and subscribe to my channel.